Okay, here you go. So what's the present value of $50,000 per year for 15 years if the interest rate is 7%? So, when we use the function key to calculate the present value, is same thing, but the only difference between the previous one and this one is we can use the information of payment now, not future value. All right. So the function key is present value is same as the when we calculate the to calculate the present value in the simple, or just one time simple the question. So present value, the rate is 7%, the number of period is 15, and now we put the information of payment now, not future value, right? Payment, because the we received $50,000 per every year for 15 years, right? So what is the present value of $50,000 per every year? Okay, so this is gonna be payment, not the simple cash flow stream. So definitely to get the positive answer, we need to add the negative sign in front of the payment. Then if you click the confirm, then the answer is 455,396. So the method, the way to calculate the present value annuity, same thing, same as the present value. But the only difference between the present value annuity and present value is the in present value annuity, you should enter the information of payment instead of future value. All right, that's the only one difference, major difference, major difference. Then how can you calculate the future value by the same token? Click the equal sign, then the function key comes out. We can find out the function name of future value f3, and the interest rate is 7%. The number of period is 15 years. Now you need to enter the information, not the present value, but the payment, right? $50,000. And to get the positive answer, you need to add a negative sign in front of payment. Then the answer is 125,6,451. So what is future value? $50,000 per year for 15 years if the interest rate is 7%. So if you receive the 15 years for every 15 years, $50,000 per 15 years, and if interest rate is 7%, then how much you will receive as of year 15? The answer is 100,256,451. All right. And so far we talked about the ordinary annuity, right? So as I told you, ordinary annuity, cash flow occurs at the end of each period. Okay, but how about the ordinary due? In ordinary due, we receive the payment at the beginning of each period. Then what's the difference between ordinary annuity and annuity due? So in ordinary annuity, we assume we can receive the amount is at the end of each period, right? How about the annuity due? We receive the 100 at the beginning of first period, 100 at the beginning of second period, 100 at the beginning of third period. So now we can compare the cash flow stream of ordinary annuity versus annuity due. So let's take a look at the future value of annuity first. Then if we are in the year 3, then the 100 that we will receive at 3 is 100 as of year 3. This is 100 is 100.1.1. This 100 is 100.1.1 square, right? If we calculate the ordinary annuity as we did, how about the annuity due? So if we receive $100 at every year, not at the end of each period, but at the beginning of each period, this 100 is going to be 100.1.1 as of year 3. This 100 is 100 times 1.1 square. this 100 is going to be 100 times 101 to the power of 3. So if we compare this one and this one, if we compare this one and this one, if we compare this one and this one, which one is bigger? This one is bigger. This one is bigger. This one is bigger. How much? 100 times 1.1, right? Times 1.1, times 1.1, times 1.1. So annuity due is bigger than ordinary annuity as much as 1 times 1.1, right? So if you take a look at the future value of annuity, how about the present value of annuity? So by the same thing. We already figured out this 100 is 100 divided by 1.1. This 100 is 100 divided by 1.1 square. This 100 is 100 divided by 1.1 to the power of 3, right? How about annuity due? In annuity due, this 100 is 100, right? This 100 is 100 divided by 1.1. This 100 is 100 divided by 1.1 square. So if we compare this one and this one, this one and this one, this one and this one, which one is bigger? Annuity due is also bigger than ordinary annuity when you calculate the present value of annuity as well as the future value of annuity as much as 1.2 times 1.1. So as you can see, not only future value of annuity but also present value of annuity, ordinary annuity due is bigger than ordinary annuity. So we can conclude that if you receive the payment at the beginning of each period, not at the end of each period. So if you receive the payment at the beginning of each period, then the present value of annuity as well as future value of annuity is bigger than when you receive the payment at the end of period, right? Okay. That's explain. So the future value of annuity due, it can be calculated by future value of ordinary annuity times 1 plus I. So the future value of any ordinary annuity in the previous example, the answer is 331. But the future value of annuity due with the same example, the answer is 364.1. So the future value of annuity due is bigger than future value of ordinary annuity. So the present value of annuity due is also bigger than present value of ordinary annuity. So we already figured out the present value of ordinary annuity in previous example. The answer is $248.69, but the present value of annuity due is the 248.69 times 1.1 is going to be 273.55, right? So the ordinary annuity due is always bigger than the annuity due in both the future value of annuity or and the present value of annuity. Okay. Then next topic is perpetuity. Perpetuity means the stream of equal payment at a fixed interval. So the same thing as the annuity, equal payment, same thing, payment, right? Fixed interval, same thing. Different. So now I already explained the three characteristics of annuity, right? First one is equal payment. Second is fixed interval, 1.5 the fixed interval, right? Third one is what? In annuity, there's for the specified number of periods, right? The period is specified, the number of periods, but perpetuity is what? Continue, right? Continue forever. So we can receive 1, 2, 3, 4, 5. We can receive the $100 today. We can receive the 1 year later. We can receive the 2 year later. We can receive the 3 year later, 4 year later, 5 year later, 6 year later, 100 years later, 1,000 years, 1 million, forever, right? Forever. So you can receive, we can receive the payment forever. Yeah. So is this possible? Yes, it's possible in real life. So the Britain government issued the government bond in say 18th century, 17 8 something, to the raises of fund. So at that time, for example, the principal is $100, but the interest rate is 10%. Then Britain government the provide the $10 per every year, forever, right? So then you can receive the $10 this year. You can receive the $10 2022. You can receive the $10 2023, and you can give this bond to your son. Your son provide this bond to your grandson. Your grandson provide this grandson. Great grandson. Great grandson. Right? So you can we can do that, right? Then, so this is possible financial instrument, right? In real life. Then we can calculate the value of those kind of this one is called as perpetuity. Perpetuity means what? We can receive the equal payment at fixed interval forever. So, and we can calculate the value of this kind of cash flow stream. How come? This is what you can recall the formula, but just same as the sum of finite infinity series. This is what? Sum of infinity sum of infinity geometric series. When we calculate the annuity, we use sum of finite geometric series. But when we if you want to calculate the perpetuity, we need to use the sum of infinity geometric series. What is sum of infinity geometric series? By definition, sum of infinity geometric series, there's some name of the Boy group, infinity, blah 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 blah. So sum of the geometric finite infinite geometric series is the what? A divided by 1 minus R. A is the initial term, R is the common ratio, same as the the sum of finite infinity series. So in this example, this 100, 1, 2, 3, 4, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100 forever, right? So this 100 is going to be what? 100 divided by 1 plus I. This $100 that we expect 2 years later, this is as of today, this 100 times divided by 1 plus I square, right? So this is the first term is what? Payment divided by 1 plus I. What is the common ratio? 1 divided by 1 plus I, right? So if you rearrange this equation, payment divided by 1 plus I, 1 plus I minus 1 divided by 1 plus I, 1 plus I wiped out, 1 minus 1 equal to 0. So remaining one is what? Payment divided by I, okay? So if we receive $100 forever, and the interest rate is 10%, then the value of this kind of cash flow stream is going to be $1,000. Okay, that's perpetuity. Okay, and the third topic is uneven cash flow. So far, we assume that we receive the same amount on every the period, right? 100, 100, 100, 10, 10, 10, 20, 20, 20, right? But in real life, we will receive the different the amount of the cash flow, right? $100, $300, negative $50. Then we cannot but calculate one by one, right? So this is the 100 divided 1.1, interest rate 10%. It's gonna be 90.91. 300 divided by 1.1 square. How can you get this one? 300 divided by 1.1 to the power of 3. How can you get this one? 50,000 divided by 1.1 to the power of 4 is going to be negative $34.15. If we sum up this cash flow stream that we expect from the first year to the last year, fourth year, the present value is going to be $530.08, right? So the multiple cash flow using spreadsheet, you can use the present value or future value functions in the Excel to find present value or future value of a set of cash flows. So setting the data is half the battle. So as I told you, if you face some questions in terms of time value of money, then you should figure out what question is. first, right? So you can figure out that question is to figure out the future value, present value, interest rate, number of period, future value of annuity, present value of annuity, perpetuity. So if you take a look at the questions, you should figure out the what question is first, right? So setting the data up is half the better. So if you the input the figure in the cell properly, then the next step is not conducted by you, but conducted by what? Excel, right? So the only the should do, the thing that you should do is what? You should put the proper number in the Excel spread, in the each cell, right? That's it. So if you click the example, here you go. So if we expect the $1,000 1 year later, $30,000  2 years, 2 years later, 5,000, 7,000, 9,000. Okay, then we cannot but calculate one by one, right? So this one is what we need to. We want to get the present value, right? So present value rate is 15%. The number of period is 1 year later, so on. Not payment, future value is $1,000. So definitely, if you want to get the positive number, you need to add the negative sign in front of the future value. So if you conform, then you can get the $870 as of today. Okay. So let me give you some the very useful tip to solve this question very simple. How come? If interest rate is fixed, then it's very easy to solve this question. How come? So from now on, this is not finance technique, but Excel skill, right? So if you add a dollar sign in front of cell, then that cell is fixed, right? Fixed, right? So, and then you don't have to calculate one by one. Just once you set the formula, then if you drag, then automatically you can get the answer, right? So if you you can just sum of this one, then you can get the answer. Here you go. So I gave you some the tip to solve this question uneven cash flow very easily. Time's up. Oh, okay, time's up. So let me stop here. Sorry for intro.